Hi, this is Brad, and welcome back to the Analog Universe. This is episode 7, Gravity, part 2. So in episode 6, I postulated that gravity is kind of like a cosmic whirlpool in which these subparticles, these subatomic particles that are ubiquitous and everywhere, kind of like a great cosmic whirlpool in which all the planets and asteroids and other massive objects in the solar system are caught up and brought along in the orbits around the sun, the earth, and the other planets. So this means that the closer an object is to a greatly massive object, the faster it has to orbit. Just as a whirlpool spins slower on the peripheries of the whirlpool, so it spins faster the further and further you get down into the whirlpool. And so a satellite in low Earth orbit orbits the Earth at about 17,000 miles an hour. A satellite in geostationary orbit, which is significantly further out than a satellite in low Earth orbit, orbits the Earth at about 7,000 miles an hour. And if you go all the way out to the moon orbits the Earth at about 2,200 miles an hour. Same with the planets. The Earth orbits the sun at about 66,000 miles an hour. Mars orbits the sun at about 54,000 miles an hour. Jupiter, the next planet out, 29,000 miles an hour. And if you get out to Saturn, it slows down to about 22,000 miles an hour. So obviously this flow of objects is much more significant and much faster the closer you get to the sun, etc. Until you get very close to the surface of that object, to the surface of the Earth, for example, when these subparticles will then be caught up and be going straight down towards the center of the Earth. So what pulls these particles down towards the center of the Earth? And here, I'm just asking what if. I don't know that my answer is correct. I'm just saying, if you've lost your ring and you think it fell under the couch, look under the couch. But if you've looked under the couch for a long time and you can't find your ring there, look someplace else. Here's me looking someplace else. What if, given significant pressure, these subparticles fuse together? Okay, well, the center of the Earth would provide more than enough pressure to fuse these particles together. And so let's look what would happen if that's the case. In empty space, last episode, we saw these particles would act as atoms of air, keeping each other at a certain distance. And they would all have equal pressure on all sides. But if suddenly two particles fused together, that would mean that the particle that was next to the particle that just fused would have pressure on one side of it, but on the side where the particle next to it had just left its space and went to fuse to another particle, there would be a vacuum or no pressure. So there would be pressure on one side of the particle, but on the side of the particle where its neighbor just fused to another particle, there would be less pressure. So that particle would rush into the void to fill that empty space. And then it would, of course, fuse to the particles in the center, leaving yet another void for the particle next to it to rush in to fill the void and ultimately fuse, and leading, of course, to a cascade of particles rushing into the center and fusing. Think of it as an airliner at 30,000 feet, and a window plug just blew out of the airliner. So you have a gaping hole in the side of that airplane. Now at 30,000 feet, you've got a pressurized air cabin so that the air pressure in the air cabin is significantly greater than the air pressure outside the plane. The pressure between the air molecules in the cabin is a lot greater than the pressure between the air molecules outside the plane. So the window plug blows on that airplane and you get a sudden rush of air from inside the cabin flowing outside the cabin, flowing from the place of greater density inside the cabin to the place of less air density outside the cabin. That is what I'm postulating. It is what's happening at the center of the Earth, at the center of the sun, at the center of planets and massive objects, even at the center of some of the larger asteroids in our solar system. This is why these SUM particles are rushing down to the center of the Earth. They're rushing from an area of greater density to an area of less density because these SUM particles in the center of the Earth are fusing together at a very rapid rate. So these SUM particles, they're ubiquitous, they're everywhere, and they're massive, only slightly massive. Each particle only has a tiny bit of mass, but it's massive nonetheless. So if you're standing on the surface of the Earth, holding a ball, and you let that ball go, a SUM particle on its way down to the center of the Earth will come down and hit an atom on the top of that ball, pushing it down ever so slightly. One particle will only give a very, very, very slight push downwards, but they're ubiquitous. There are millions of these particles hitting that ball at any one time. And the effect of all these particles hitting the ball at the same time pushes the ball down. That's why when you release the ball, it starts dropping at a slower rate and picks up speed at the rate of 9.8 meters per second squared. Okay, so you would expect if you went further out from the center of the Earth, there would be fewer of these particles hitting that ball that you dropped. And in fact, if you went to the top of Mount Everest and dropped that same ball, it would fall ever so slightly slower, 9.77 meters per second squared. Therefore, under this hypothesis, don't think of gravity as something pulling you down towards the center of the Earth, but more as a cosmic rain falling on you and pushing you down towards the center of the Earth. Yeah, Phoebo, I don't know either. But no one's found that ring under the couch. No one's been able to square the quantum worlds and the relativistic worlds after 100 years of looking. I'm just looking elsewhere. The Ptolemaic fallacy is a real thing. It kept knowledge about our cosmos from advancing for over 1,000 years. Has it kept knowledge of our cosmos from advancing for the past 100 years? Because Einstein got the math right, but his underlying theory was wrong? I don't know. It's worth looking someplace else. It's at least worth taking a look. I'm offering a different direction to look in. A scientist right now, looking in a different direction, would risk getting caught in the peer review funnel. Much worse than that, he or she would know that they're facing the disapproval of their fellow scientists. That can damage a career and even be career ending. And that happens. Scientists that disapprove of other scientists looking in new and novel directions are carrying on a centuries-old tradition of persecuting the other, of people who think outside the lines. It's crucial that we allow thinkers to think, to explore new areas of thought. This needs to be encouraged, not persecuted. I'm just saying. Let me know what you think. Do you agree with me? Is it possible that gravity could work this way? Do you have another idea about how gravity could work. Agree with me, disagree with me. Have another idea? Let me know your thoughts. And if you agree with somebody who posts something here, let us know. If you disagree, we want to know that too. But always remember what Phoebob says. Be kind. So join us next time when we finally talk about the Michelson-Morley experiment.